I am currently reading this very great book. It's called Discrete Math with Applications by Susanna Epp. And I really like the book. I've started reading it, getting into a bit of discrete math. And so in the second chapter, they're talking about logic. And like, you have statement A, you have statement B, and then statement A and B only returns true if both statements are true. And so within the book, they have multiple examples of these called truth tables. And so here you can see that we have statement P. Here we have the negation of statement P, basically kind of the inverse. So if P is true, then this one will be false. And here is the kind of add operator, or the conjugation of the two statements that add them together. And as you can see, you can compare the different values of the different statements. And so what I wanted to do was basically make a dynamic generator that can generate these tables where you kind of like input your variables and different kind of statements, and then it checks if they are logically equivalent. And so that's basically what I'm doing. And so the first thing that I'll having to set up is kind of the initial combinations, because what you have to do is that you have to combine it in every way possible to make it a complete truth table. And so here I have the variable p. Now if I would add a second variable, say q, then I will have to have different combinations, and I have to add these also into the table of the possible combinations. And so we need to check for every single combination if this statement is true, but this one is false, but this other one is false. And so the first thing that I need to do is kind of to generate all the different kind of combinations, even for like 10 different statements, so that we would kind of have everything that. So the first thing that I was kind of thinking was that I'd label a false statement as 0 and a true statement as 1. And then I'd create a set, and then what I basically have to do is that I have to maybe create every single combination between the sets, and so it would have to walk some type of path. And then I was thinking that like it kind of forms this kind of like tree-like structure. And then the first thing I tried to do was that I tried to implement it using arrays. However, this was kind of ineffective. And then I heard about the data structure called a tree, where you basically have an object where each node element, so to speak, points to the next node. So you would basically have a parent here, and then it points to two children, which contains the elements that you want. And so this is what I landed on. And so also here is an example where you can see all the different combinations of, say, when you have to choose three numbers, three statements, and 0 indicates that the statement is false, and 1 indicates that the statement is true. And so you can see that there are 8 different combinations. That's 2 to the power of 3 different combinations of combining these. And so I needed kind of this tree-like structure where it would first start an object, and then it would divide up into this one could be true, and so this would kind of form different paths, you see, because the first statement can be true, or the first statement can be false. So this would be P1, and then this would be P2 and P3. And so the first statement would be false, the second statement would be true, and the first statement would be false. And so this would form 0, 1, 0 with that combination. And so this was kind of what I was going for. The thing is, I haven't implemented a binary tree before, but we'll see. I think it will be very fun. Okay, so I'm going to try to implement this tree in JavaScript. So what I basically want is that I want an object where a binary tree where it splits into zeros and ones. So I don't really know how to do that, but I'll just try playing around and see if I can manage to make it work. Otherwise I'll have to look something up. But as I get it, you have to have for every key, for every separate key, or for every separate element, you have to have some pointer, or some key that points to the next value in the chain. So I'll start with that, and we'll see how it goes. Okay, so I'm kind of trying to figure out where to go with this. I found this pretty useful. Yeah, so I found this pretty useful article by Geeks for Geeks. So I'm kind of following along in this blog, but it seems like kind of what they're doing is that they have a class for the binary tree itself, and then what we basically do is that we want to insert, and then we have a separate class which is just for vnode, which is what I have right here. And then what we basically do is that when we want to insert data, we create a new node, and first we check if there is like anything in the root, like if we have made a root, and if we haven't made a root, then that new node will be that root, but otherwise we will insert data as we do normally. And so we call this new function where we have where we insert data at the current root, and what we're inserting is the new node. And so what it then does is that it then kind of checks like if the data is less than the previous data, so that it would determine if it will go to the left or to the right, depending on if the value is less or more. And then it basically just checks if the value is defined, and if the value isn't defined, if it's set to null, then it will instead replace that null value with the actual value, and otherwise it will just kind of call itself recursively, and so it will go back and then it will return again, and so it kind of creates this tree-like structure. However, I'm a bit confused, or a bit uncertain how I would apply this to my specific use case, because what I want to do is that I want to I don't want to have like fours and fives and threes. You know, I don't want to have this sorted tree with just numbers where it's sorted after value, which is what it's doing here. But what I want is, you know, to have like zeros and ones, or like false and true boolean values. So I'll see how I'll implement that. Yeah, I'll have to think about that. Okay, so I think I'm running into some issues that's related to types, because I think just because the root was undefined, but I missed that, so I'm going to switch over to TypeScript to avoid those issues. Oof, okay, so I think I fixed all of the errors, so now TypeScript is very happy, and let's continue on. Okay, so it seems like we actually have kind of a working tree, just that I have to tailor it to my specific needs. But as you can see, we have a tree object right here, and it has the first root object, and then within this we have a left and a right, and then we have the value right here. And then if we go into the left, then we will see that it has a link to a bunch of other nodes, and then within each node we have the value, and as we can see, they are incrementing by one step over each iteration. So now I just have to make it so it becomes this binary 0, 1 tree, or something like that. Because maybe I'll just change the value to a boolean value. It will be true or false. But I'll have to see how I'll do that. But I think I'll start with numbers, because I think zeros and ones are a bit easier. this is what I want. I want this binary tree. I just don't know how I'll sort this out. Okay, so I think I might have one idea. So my idea is basically that I think I'll have to make a recursive function. So what I think I'll do is that I'll make a separate function that what it basically does is that it takes in a parent node, and then it generates two children, two nodes, one with the value of 0 and the other one with the value of 1, and it recursively calls itself each time for each child to generate two new children of every child, and then it keeps doing this. So this would be n is equal to 1, n is equal to 2, n is equal to 3 for every row, up until the amount of rows that I used. Alright, moment of truth. Let's see. You get a 3, you get a left value. Oh shit. So the good thing is that it seems to have worked in a way. I mean, like, the problem is that we haven't got any values on the right of the tree, but as we can see, the values on the left are kind of oscillating between 0 and 1 over each iteration. So I'll see, because the point is not that the values should iterate every time, because the point is that the 1 will go on the right and the 0 will go on the left each time. So it generates the right values, but it doesn't really place it at the correct place. So I'll look into that. Oh my god, I just put in this string left as a boolean value. I mean, like, come on, that TypeScript, you're supposed to help me with this. Okay, so we got the left and we got the right. Okay, so this is what I call progress. So we got this tree now. It has a problem because, as you can see, it fills in the values 0 and 1 properly on the left and the right. If we click on the right node, then we'll see that it doesn't point to any other left or right. So we gotta fix that. Oh boo boy! Look at it! I made it! I've got this nice tree. Damn, okay, this is actually harder than I thought. So as you can see, we have um like we have a 0, a parent element, and then each parent has two children. One is 0, one is 1, and we can see how it moves down. And so now I have generated a tree with 10 rows, so it keeps on going. And then if you click, oh no, wait, maybe that was the end. Okay, yeah, I reached the end of the tree. I thought it was broken for a second. Okay, and this is exciting. I want to do a bit of just small adjustments and do a bit of comments, and then I'm going to move on to kind of traversing the tree so that I can generate different combinations, to generate the different true or false values for each variable. Okay, so I've fixed it up now, added some nice comments, and let's get started on actually traversing the tree so I can generate the different combinations that I want. Okay, so I think I'll have to do some kind of recursive loop again. So I don't really know, but I think I'll have to kind of set up some function that first visits a node and then it visits the children separately. What I'm a bit unsure about is how I will generate the list, because my end goal is to generate all the different combinations. So I'll think about that. Yeah, so what I'm kind of thinking is what I'll do is I'm thinking that I will traverse the tree. So I think I'll visit a node, and I'll recursively visit first the node to the left and then the node to the right by calling the same function again. And then it will go about this way, and then it should firstly reach the farmost left bottom node, and then the farmost left one step to the right node. And so it should iterate through every branch down to the bottom leaf. And then what I'll have to do is that I'll have to put the values of each separate node as I'm traversing boundary in a list or an array. And then I think I'll have to cut it out each time. Oh wait, but it could be. Yeah, okay. I'll just get started and I'll see where it goes. But I think might need some modifications. Okay, so it seems like the algorithm worked as I thought. As you can see, we have first it goes to 0 0. I can show you because my camera is dead, but you can see that it first goes to 0 0, and then it goes to 0 1. It makes sense, but I can't really show you. But I'll just have to figure out how to make it the way I want to. Okay, so my plan is to add a depth variable which will keep track of how many values I need to pop to make sure the algorithm runs correctly. So let's implement that. Okay, so this is just a quick explainer. So what I have managed to do is that I have managed to create my binary tree. So we go 0 0 1 1 0 1. So each node has two child 0 and 1. Now what I want to do is that I wanted to make linear combinations, right? So I wanted to have like 0, 0, and then 0, 1, and then to combine 0 and 1s in all combinations possible when I want two numbers. So this is the algorithm that I kind of came up with. So firstly, what it will do is that it will traverse each node, and it will start by going to the left. So first it will go to the left, and then it will recursively call itself once again, and it will go to the left again. And it will keep going till the children is null. So this is just null and null. Basically, there are no children. And when it reaches this point, and each time it traverses a node, it saves the value of that node. So when it comes across this node, it goes into kind of what it calls a recorded value, or what I at least call the recorded value. And so it stores the values, and so first it comes to 0, so it stores the first 0, and then what it does is that it goes to the next 0, and so it goes to 0. And now there is null, so now it stops. And when it reaches the length, when the set reaches the length of 2, which is the number of rows, then it creates this kind of buffer, or not a buffer, but it creates all the different branches, and it lists this branch as a path. So one path from the root down is 0, 0. So this is the first path. And now that we've reached the end, what it does is that it pops off an element, and then it goes back up because it first went to the left, and it recursively will go to the right now. And so now it will end up here, and it will save this value right here. And now the length of the array is 2 again, and so it will add that as the next branch. And now it will have to pop off both elements, 2 elements. It will have to pop off both this one, and then start off here, because this is now where it will end up, because it first went down this road, and now here. So I was like, okay, so how will I know how many elements to pop off? Well, so what I basically think of is that we have a depth variable, and it's counting from downwards upwards. So when we are down here, all we need is to pop 1, because we only need to pop 1 element to move on to its sibling. But if we are here up, well then this element has 2 children, and so we need to pop both its children and itself. And so it has a depth of 2, because we need to pop 2 elements to move up to its sibling. So now it will pop off 2 elements. So the number of elements that it pops up is the depth, and we start off with the depth being equal to the number of rows in the tree, and then we decrease the depth by 1 over each iteration as we go deeper down the nest. And so the next one will be 1, and now we go to the left, so that's 1, 0, and now we have once again filled the array to 2 size, so we add another one, and now we are at depth 1, so it pops off 1 element, then it goes to the next one, which is the last one, and so it adds this one here, and now this is of length 2, and so it adds this. And this is how it works, and now we get our final array of all the combinations. So that's how it traverses the tree, so to speak. Okay, so we can see the level of depthness right here. So as we see, we start up at the top row, and so because we're counting inverse, then we have 2 rows, so this will be kind of the top row. And then we have the second row, so first we will be at the 0, and then the child 0, 1, and then we go back to the second row, or the first row if you're counting upwards, and then going through those children. So now all that should be left to do, if I have some luck, is to set up a for loop and pop each value for the depth. And let's see how this works. Let's just Oh, how many values are popping? Less than 2. I just gotta check that. And I want to keep track of the recorded values. So I'm going probably to take out this one because I don't need to see it. And I'm just going to console.log recorded values. Is it running? Yeah, I mean, like, it should be. But why isn't it? Hello? Okay, so it is running. But yeah, let's just rewrite this. But no, why just no, please? Why though? Oh well, that's 0. But maybe like if I do this. Oh wait, hey look, it seems to be working, but not entirely. And I'm kind of unsure why. Maybe it just needs to run for one more iteration. Did 2 pops the way that it's supposed to. But then the problem is just it just didn't complete the final iteration because it seems to have done everything basically correctly. The problem just seems that it didn't go to the last node. Okay, I think I gotta debug this. But why won't it work when all I wanna do is to debug? I just want... Yes, let's go. Okay, yeah, so it hit the JavaScript file, which is exactly what it does. And now it should enter the right child, and this is where the problem should come up. And it doesn't enter the right child. Yeah, what happens if we just remove this? Because we're already checking if it's null at the top. It would make me so happy if things went all right. Let's I'm going to try I'm going to do what's called a pro gamer move and try to increase the load to see if anything changes. Okay, so as you can see, it kind of fails at the topmost layer, so it works kind of like very nicely for the first half, as you can see, but then when it switches to 1, when it's supposed to do that final switch, it just won't work. Oh no, wait. No, the combination is not 3 squared. It's I wrote it out, and I think it's actually it's 2 to the power of 3 because it's 2 times 2 times 2. Now that actually makes sense because like for each separate place you get to choose from. You could choose a 0 or a 1, next one would be a 0 or a 1, and next one would be a 0 or a 1. So the final problem is that it just won't get the final one right, and I just don't know why, man. Like, just why? Come on, we were this close to perfection. Come on. Okay, but let's just, because otherwise it seems to work very nicely. I mean, like, look at this. This is just magic. Like this does put a smile on my face, but
Why won't it just get me right last one correct? Like, come on, we were this close. You were just supposed to put a 1 on the end. But why won't that work? Yeah, I'm going to debug this one more time, and I'm just going to try to use my brain, and we'll see how it goes. No. So it follows the proper sequence, but for some reason it just doesn't? Well, like, why? Like, I could just add a cheat. Because I could just... I know that for some reason there's a bug, so I could just kind of like cheat it out, because I know that it's just at the last one, so I could just add it in kind of like manually. That's, I mean, like, it should be an easy solution, but I'm like, it's not as nice. It's not as nice. I just want it to work nicely. Yeah, I'm going to cheat actually. Kind of sad, because I'll probably figure it out later on. But for now, just so that I won't get stuck on this, I'll just I'll create a for loop at the end. Okay, now it should be finished. Let's see. I was going to remove the breakpoint. And you can see that we got our array and we got our true values. So now let's just scale this up to some crazy numbers so that the computer crashes. And oh boy, oh no, I should have removed the console log statement. Oh man, okay, let's just, yeah, we don't need this. Let's see, is there any other mention? We just want the one that and like the tree we don't need, we just want to look at the branches. Holy shit, we got the array, boys. Okay. Nice. Nice. Okay, this is very nice. Oh man, you just gotta love these numbers. The hard work is paying off. Finally. Okay. Wow. Okay. Yeah. Shit. No. That. Damn. Okay. So I've got now given basically now I got all combinations you can have between ones and zeros, or true or false values. So now I can finally generate my table, which is I guess what was the point the whole time. So let's just do that. I'm just going to do some cleaning up, I think. Okay, nice. Yes, I managed to do it. I have the tree. Now let's just do the final step, which is to finally display our data. So let's just do that quickly. Okay, well, this is a bit more nice. I think 20 is more appropriate. Okay, that's cool. And I only want that many values. Okay. And then I just want to put out the first value of the column. Yes, let's go. Okay, I think I've got it. Let's see. Okay, so now we should have our entire table. And then the last thing that I want, just to complete this kind of prototype, is that on top of my table I want an input. Okay, so I think this is pretty nice. I mean, like, it's not super performant, but as you can see, we get all the different combinations for the different values. So now we can generate if you want everyone to be false, and then at the bottom everyone will be true. Then there will be one false here, then one false there. So this should be every single combination possible. And then what I'm planning to do now is that I'll clean this up, and then I'll start building the UI in React. And then I'm thinking to the ability to add logical equivalence. So this is so if you're not entirely following along, then this is meant to be statement 1, and statement 2, statement 3, statement 4. And so now the next part would be to add the different kind of like statements 4 and statement 3, and then it will see, depending on the different values of these statements, will the conjugation of those two statements will that either be true or will that be false. But I think I finally managed to do the main thing that I wanted to do, so that's kind of fun. But I still got a bit more to do before I really reach what I want. Let's see if it can go for 9 statements. God damn. I like this, is super nice. Let's just try to break it. Because before it was 2 to the power of see, before it was 2 to the power, no, not 22, 2 to the power of 9. This would have to generate 512 values. But now it's 2 to the power of 14. While trying to display 16,000 values. Maybe that's a bit too much, but like 8? Oh, okay, it's already crashed. Let's just see where its limit goes. I think it should be able to handle 10, probably. That's 2 to the power of 10. Let's see, 2 to the power of 10. That's 1,000, so it would have to display 1,000 values. And yeah, I think that's about the limit. So you can see that it creates all of these different kind of type of combinations. That's very interesting. That super cool. Let's build out the React and make it even better.